The last major operation we want to talk about when dealing with data is the merge operation.
In the world of the Transformers, nothing is what it seems. Meet the Constructicons, 6 evil robots that transform into one mechanical giant.
The Transformers, more than meets the eye. The Transformers.
It's Devastator! 6 Constructicons in one! Devastator's attacking!
Constructicons gift set sold separately from Hasbro.
Constructicons, merge for the kill!
Cop, Hot Rod, look!
Devastator.
Prepare for extermination!
I think we can help.
Merge into Devastator!
The last major operation we want to talk about when dealing with data is the merge operation. And that's when our data lives in multiple different files and we need to combine those files to make them easy to work with into one flat file. So where did we see an example of that? Well, we saw that with the telecommunications data, where we had one data set that went through and talked about, well, here's each customer, how long they've been with the company, what kind of contract they're on, if they did or didn't churn. And then we had a different data file that told us something about what subscriptions they actually were a part of. And we also had a third data file that talked about demographics. So if we wanted to study the probability that a female that had been with the company for at least 3 years and who streamed movies or TV was a churner, well, we'd need to get information from some of these data files to play nicely with each other. We need to create a flat file, have all that information in one place. And so that is going to be our goal with merge. We're going to take data from one data table and put it into another data table. So the syntax of the command in R is just merge the two different data tables that you're kind of mushing together, combining together, and then exactly how that merge is going to take place. Now, before talking about what are all the little bits and pieces, the arguments that you have to set up in order to get the merge function running correctly, just a bit of a narration about how this is going to proceed behind the scenes. So what exactly happens when we merge together two different data sources? Well, the first two arguments of merge, I've denoted data.x and data.y. The ordering of these two arguments matters, and in fact we're going to call data.x the left data frame, and we're going to call data.y the right data frame. And this has some analogy with how you would learn how to do this in SQL. And the way that I like thinking about what happens when I run a merge is I say, okay, what's the very first data frame in the merge command? What's that left data frame? That's the data frame that we're going to start out with. And the other data frame in the arguments, that's the data frame that contains information that we want to borrow, that we want to drag into the data frame that we're starting with. So in this case, we might have as the data frame we're starting with the churn data frame, where we have the customer ID. We know if they did churn or if they didn't churn, something about their tenure, their monthly charges, etc. And if I wanted to study the probability that men versus women churn, I would need to get the gender of that customer into this data set. That way I could compare the two proportions. And so that's what merge is going to do. I want to start out with this data frame, the churn data frame, and I want to add in additional information from the second table. So I basically want to go through and for each customer, go find where that customer is in that second data frame on the right, and then extract out their information about their gender, their senior citizenship status, partner, dependent status, and add those in as new columns, ultimately ending up with something like this. The result of the merge will be what the data that I started with looks like, and then adding in those additional columns to fill out the information about each of those customers. Okay, we just have to tell R how this merge is going to take place. How are we going to match up the individuals in one data frame to the individuals in the other data frame? How do we match the left and the right data frames to each other? That's going to be controlled by the by argument. So schematically, how is this going to work? What we're going to do is we're going to pass it a column name, or if they have different names, we'll have to do a by.x and a by.y that let us know how that matching is going to proceed. So here is the column of customer ID in the data set that we were starting with, the left data frame, and here is the column name in the right data frame that contained that demographic information. So what we'll do, just in English, is look for the customer ID in the left data frame, find where that is in the right data frame, and then borrow that information, put it into where we started. So we're going to use the customer ID column to match both data frames to each other. So in the by field for that argument for merge, I'm just going to put the column name in quotes that tells me how to match or link the two data sets together. Now, sometimes it might be the case that one column isn't quite enough. Imagine I had these two data frames, people and stats. We have a column first and a column last for first and last names. Notice that if I'm going to borrow information from the stats data frame, like the number of pets, the number of cars, and I want to add that into my people data frame, I can't do that just by looking at the values of first. Because if I were to say by equals first, I'd say, okay, well, where's my information about Adam? Well, there's two rows denoted for Adam here. We have Adam in row 1, we have Adam in row 4. So R is going to be like, I don't know which one you're referring to. I can't do this. Likewise, I can't say, well, let's do this by the column last. If I tried to link up Petrie, well, I see Petrie in two places once again. Which of these two rows am I actually going to drag over? So technically, if you're good with SQL speak, what has to happen is that what you pass in the by argument actually needs to be the primary key of the second table, the table on the right here. Primary key is a column that has a unique value for each row. It essentially uniquely identifies the individual in that table. So in this case, there is no single column that's a primary key for the data frame on the right here, the data.y, but R will allow us to merge on the combination of columns if we just pass that as a vector. So for that first example, where we're just taking the demographic information from the data frame on the right, putting it into the data frame on the left, our by argument can just be customer ID. So if you find that when you're merging two different tables and you can't just match them up by a single column, and you actually have to match them up by combinations of values you find in two or more columns, what do you do with that by argument? Well, you just pass a vector of the column names that form that composite key in this case. So if I did want to start out with the people data frame and add in the number of pets and the number of cars that person has from the stats data frame, well, what I'm going to do is I'm going to have as my by argument be the vector of column names in quotes that I need to use to match up an entity in one table to an entity in the other. So the combination of first and last uniquely specifies the individuals in the data frames, so by equals first last as a vector. If I fail to recognize that's what I need to do, well, I would end up with very kind of bizarre looking results here. So make sure that when you have a composite key, when you actually have a combination of columns you have to use for your merge, you just pass those as a vector. Now here's one thing you might not like about the way merge behaves by default. So here, imagine I want to add in information about the rate and the length for each of the plans our customers are in. We want to merge customers' plans by plan. Here's what R does by default. R says, okay, well this plan column must be pretty important because that's the by argument here. That's what you're using to merge these two different tables together. So R says, well, let's go ahead and sort by that by field. So you'll notice that when we merge customers and plans, the ordering of the names, the ordering of the IDs is now out of order because it's sorted based on the values that it found in plan. Now, a lot of times you don't want that to happen. You want to preserve the ordering of the rows in your left data frame, your X data frame. How do you do that? Sort equals false. We'll make sure that the result has the rows in the same order as the left or X data frame, the data that you're starting with. In this case, if they have different column names, well, we would specify what those columns have names for the X and the Y data frames, the left and the Y. On the left, it's called customer ID. On the right, it's just called ID, so by.x and by.y. Still a little like subcomponents of that by argument there. All right, so let's work through just a very brief example, kind of one that makes sense visually. What if we had these two data frames, customers and plans? So customers is a customer data set. Each customer has a different ID. Each customer has a name, where they live, and what plan they subscribe to. Plans is just a data set that contains information about each plan in the data set. So what if we wanted to add to the customer's data set the information about what plan they're on? So let's add a new column for rate, add a new column for length to customers essentially, that let us know what the rated length of these plans are. So if I were to do that, well, I could set up merge by passing as those first two arguments, just the names of the two data frames. I'm starting with customers. I'm adding information from plans, so that'll be the ordering, left and right. The way I'm going to match up the two different data frames is with the plan column. Notice the plan column on the Y data frame, the right data frame, is the primary key. The value here in plan uniquely characterizes and specifies what row I'm looking at here. So I'm simply going to go, okay, well, where's plan 4? Here's plan 4. I'm going to drag 40 to a new column rate, and I'm going to drag 60 to a new column length. Plan 2, I'm going to drag 15, I'm going to drag 30, etc., etc. So same column name, by equals plan. What would happen if we actually run that? Well, here is another complication to how merge works, something that we're going to have to specify depending on how we want that merge to proceed. And that is actually going to be the all argument, that last argument in that merge command, the all equals. Okay, so if we leave that out, what's going to happen? If I just straight up try to merge customers and plans together, what's going to happen is that only rows where we find values of plan in common between both data sets are going to survive the merge. In SQL speak, this is like doing an inner join here. Basically, since I don't see plan 7 in the plans table, 7's not in common to both, it's not going to get carried over to the result. 5 is not a plan that I see in the customers table, so it's not going to get carried over to the result as well. So we see poor Eliza actually getting dropped from the result of running this merge because there is no plan 7 in the plans table. Now, sometimes we would like for that to happen. We really only want to add in information from the right data frame, the Y data frame, when we actually have it. And if we don't have it, just drop those rows. That's what's going to happen by default if you leave off that all argument. What happens if we do really want to have that carried over? Well, that's where we're going to specify what we want to have as that all argument. So omitting all makes it so that only rows that appear in both DATA.x and DATA.y will be present in the result. Basically, it looks at the by column. Only values that are in both places are going to survive that merge. We have that inner join. If we want to make sure all rows in the data frame that we start out with survive that merge, even if they can't find their counterparts in the data frame on the right, we're going to put in all.x equals true. So the X data frame, that's the one on the left, we're going to all.x equals true when we want to ensure that all rows in the data frame we're starting out with survive. So we'll have to figure out, well, what do we do with this Eliza on plan 7? We don't have any information about plan 7. We should probably add in NAs to rate and length there. So let's kind of see that in action. If I were to say, all right, merge customer plans by equals plan, it's going to drop Eliza because we don't see plan 7 in the plans table. If I want to keep Eliza in the result, I need to add in the all.x equals true argument. And that'll force all of the rows in the data frame that I'm starting with to survive the merge. Since it couldn't find any information about Plan 7, it's going to have NAs for the new columns that it's added. All right, we might want to do it the other way around. It might be the case that we actually want to have all rows in the right table, the Y table, to survive that merge. So, for instance, we don't find any customers whatsoever that are on plans 1, 3, and 5, but we might want the merge to have rows for plans 1, 3, and 5 anyway. I don't think it makes much sense for this example, but sometimes we want to have all the rows in the Y data frame survive that merge. So if we have all.y equal to true, that'll ensure that'll happen. Now, when we start adding in rows to represent plans we didn't see in the customer's data, we've got to fill in ID, name, and city, and not too surprisingly, it's going to fill in those with just NAs. Notice that if we have a numerical column, it's just NA. If we have a categorical variable, it's going to put NA in brackets. That's the difference between those two different NAs. All right, now if we want both of those to happen, if we want all rows to survive on the left and on the right, on the X and the Y data frames, regardless if they find a match between them, we could have the all equal true argument. And so what will happen is that all the rows and customers are going to survive. NAs will be added to the rate and to the length column. So Eliza survives there. We have NAs. And also we'll add in rows for the unmatched plans in the plans table. So we'll have a row for plan 1, 3, and 5. We don't have any IDs, names, or cities associated with it, so we have NAs there. R will allow you to do that kind of merge as well. Would you do it for this case? No, absolutely not, but you have that option